Those there. As the Earth blanks the sun. There's letter O, orbits. Yeah. Exactly. I like the first video we watched especially because how you can clearly see what we were talking about the tilted axis of rotation. One of the planets out there, Uranus, actually, its axis of rotation, it's not tilted like this. It's tilted like this. So it actually lies in the plane of the ecliptic for poor Uranus. So it's just got some very crazy seasons. If the Earth's axis of rotation were tilted, we wouldn't have seasons. It'd be the same all the time. Okay. So if we kind of focus on the northern hemisphere, June 21st is the summer solstice. Okay. Again, I say you can use, I'm fine with 21, 22, 23. 21st to the 23rd of 3 months apart, you get these major times. So what goes right there? Rays are most direct over the Tropic of, what's in the northern hemisphere? Cancer. Yep. Tropic of Cancer. Exactly. And then the Arctic Circle, just like we saw in the video, is going to have 24 hours of daylight. And I've seen it different ways. I really think the Arctic Circle is defined by, the Arctic Circle is 66 1/3 degrees north latitude. I think anything at the Arctic Circle and northward towards the poles has no nighttime. And then, like the video said, our seasons are reversed in the northern and the southern hemisphere. So in the southern hemisphere, we have the we have the Antarctic Circle in the southern hemisphere, and so it would actually have no daylight on that day. So I have this table here, and it's kind of broken up by the 4 important times as the Earth orbits the Sun. Notice I kind of did some ranges here, but if you do 21st to the 23rd, if you have on the test, you're fine. And there will be actually 3 months apart. So for this one, rays are most direct over the Tropic of Capricorn. And if you are north of the Arctic Circle, you're going to have 0 daylight hours. And if you are south of the Arctic Circle, you're going to have 24 hours of daylight. So we have 2 equinoxes up there, and you can go vernal, or I said, to me, that term drives me nuts. I usually go spring, same thing. Spring, I love the word spring. It's coming up. The vernal equinox is coming up. And then in those cases, both of the equinoxes, the most intense location, latitude for the sun's rays are at the equator, and everybody gets equal daylight. So you're looking at 12 hours of daylight, 12 hours of nighttime on the equinoxes. So the summer solstice in the northern hemisphere, rays are most direct over the Tropic of Cancer. If you are north of the Arctic Circle, you're going to have a hard time sleeping. Because it's going to be daylight all the time, 24 hours of daylight. If you are south of the Antarctic Circle, then that's where vampires will migrate. So they will have no daylight. And then we're back to our second equinox, the fall equinox. So if I call this vernal is the spring equinox, autumnal is the fall equinox. Oops, goodness, this isn't writing. I'm trying to write the word fall there. And in that case, the rays are most direct over, they're most direct over both equinoxes, most direct over the equator, and you're looking at 12 hours of daylight, 12 hours of nighttime. So it's all good. It makes me smile. I'm glad we live on the planet we live on. Does everybody get those? Okay. Because those will be on the test in some form. I don't know if they'll be multiple choice or they'll be kind of one of those short answer questions at the end. So one of the things you may or may not have, well, I know this. We all know that the sun appears to rise in the east and set in the west. This is one of the things that drive, my mom's a retired elementary teacher. This is one of the things that drives her nuts, is when we say the sun rises and sets. And it makes students confused, little kids confused, like the sun is moving or orbiting the earth, okay? But we know that if the sun's there, then the earth is well, I won't worry about the tilted axis of rotation, but you guys would tell me it's going counterclockwise, which is this, and that's why if this is nighttime because the sun's over there, then of course our east coast is going to get the daylight first. Okay, it's going to go like that, and that's when the sun appears to rise, is because the earth is rotating. But it's more of a subtle thing that you may or may not have noticed, but actually the stars also rotate, or not rotate. The stars also appear to rise in the east and set in the west. Now, not all stars, but stars that are kind of out on the horizon. If stars aren't out on the horizon, but they're kind of more at their zenith, what we call straight up and down, then actually they still appear to kind of move in a direction I'll kind of tell you about. The stars appear to rise in the east and set in the west for the same reason. We call that actually diurnal motion. This whole rising in the east and setting in the west, because the Earth's axis, the Earth is spinning on its axis of rotation. All right. So Polaris. Oh my gosh. The other day we called this Earth's axis of rotation. We said that actually then it points at a star called Polaris. Okay, and it keeps that. I know it's like, well, how can it? Because the Earth is orbiting, changing its position around the sun, and Polaris isn't moving. The deal is Polaris is so far away. There's no, how do I say? It all works. It all works. When something is so far away, there's not the movement that you would see there is. But so it's pointing at Polaris all the time. And so the thing about it, this is so cool. And actually, I'm going to try to kind of prove this to you. All right. So let's go. I'll go ahead and put my sun here, but I'm going to move my sun here in a minute. We'll talk about constellations in the zodiac. So this is my sun. This is the Earth's tilted axis of rotation. There's Polaris up there. So it's spinning on its axis of rotation, and like I think this slide says, if we look up at Polaris, which actually Polaris is in the handle of the Little Dipper, not the Big Dipper, but is it in the handle? Yeah. Oh my gosh. So it's been a while since I've been looking at stars. It's in the handle of the Little Dipper, and so all the stars go counterclockwise around Polaris. So I know it says Capricornus, but if I were to put Polaris about here, and we're going to talk about this, that actually if this is my horizon, the angle that Polaris makes is an indication of what latitude you're at. So we're about 40, 41 degrees north latitude. So that angle right there, okay, that the star makes with the horizon should be our latitude. So anyway, if this is Polaris, then I can draw the stars, and the stars would be going counterclockwise. So they kind of go like this. Little bit, little bit, little bit, little bit. In a 24-hour period, the star would go around Polaris one time. Well, if you go ahead and you're going to see it mentions a bullseye, and I'm going to show you what's called the star trails here in a minute, that kind of shows you how stars move. Just open the shutter of your camera, and you're going to see circle, 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 circle. Well, if the circles get too big, then they actually intersect with the horizon. So there's where actually, as it intersects with the horizon, make sure that's north. Yeah, this is all going to work. Things actually, if the circle gets too big, rise in the east and set in the west. Rise in the east and set in the west. And they kind of go down to that. So that's how stars appear to move through the course of one night. Okay. And it's all because of diurnal motion. I'm going to take you out to, and we'll do it a little bit again on Friday, but to a program called Stellarium, stellarium.org. It's an open source program. And how many people have like apps on their phone to look at stars? Oh, you people are killing me. Yep. So these Sky Safari, you might want to jot this down. Sky Safari, Sky View, Sky Eye. I have to think if it's worth, yeah. If you guys download one of these, because I have a pot of extra credit points, you download one of these, show them to me, and I'll give you 10 extra credit points. Good towards homework, missed homework points. It's all good. Stellarium is also for your phone, but, and I went ahead and downloaded it on my phone. I played around, there's so many free ones out there. So I think I paid for one of the versions, Sky Safari, but they have a free and a paid one. So just start with a free one and get you 10 extra credit points. But the way they work is, and you've probably seen people play with them, is it's nighttime outside, and you can put it in a mode where you hold it up and it will show you the stars or planets or whatever you're looking at in your phone, and it will move with you. You know what I'm saying? It will move with you. So it's a thought. Let's see. So this, before I do this, I'm going to go ahead and show you Stellarium. Okay, so this is Stellarium, and you guys are smart with it sort of people. It won't take you long to figure this out. I'm going to go ahead and dim the lights so you can kind of see the solids of it. One of the things about what your sky looks like is it depends on your location. Your location will tell what time zone you're in, what time of day it is, and your location, honestly, what's a player is where you are relative to the equator. If you are in the northern hemisphere, you're going to see different stars than if you're in the southern hemisphere. That's one of the things on my bucket list, going to Australia, all those pointless things down there. But I'm going to see different stars down there. Just excited to see that. So I mention that because you're going to have to tell Stellarium your general location. And I'm pretty sure it's got Keokuk, Iowa in its data bank. So it already knows my location. So, you know, the thing about it is you're like, well, where's my, well, you kind of go over here, and these are your controls, and there's also controls down here. Okay, so one of the things what I want to do is I'm going to go ahead and change the time because I can't see anything. So over here, I'm going to go ahead and go back in time, pull this up a little bit. Instead of 10 a.m., one thing that caught my eye this morning was the moon, and I'm like, wow, what in the heck is that? Well, that's what that is. See if you guys can see that. Very good. The moon, right next to the moon was the planet Jupiter. Like, how awesome is that? Where's my camera? So anyway, I'm hoping we got some clear skies this over break to go out and see Jupiter, you know, Mars and Saturn. It's supposed to be cold and all that. But if you're like me, especially kind of new, you're like, I have no idea what those stars are. Of course, what we do is we chunk stars up into constellations. So let's add some constellations there. Constellations are here along the bottom. Let's see. Okay. So over here, these are your constellations. Let's see, what do I want to do? Aha, now that's starting to look like something anyway. If you kind of stick with playing around with astronomy, trying to kind of understand what the patterns of the stars are, those will make more sense to you. Another thing that Stellarium does, and most programs do, are you can do this. This will scare your little kids, your nieces and nephews. Okay, so yeah, and I guess the other one maybe gives its, do we not have names on there yet? Okay, there's the names. So what I don't say scientists have done, maybe it was astrologists. Okay, astrologist versus an astronomer, astrologer. Astrology is the whole sign of your zodiac, and it's kind of it's a pseudoscience. It's not really a science, but interested in it. Okay, astrology a little bit. But it has nothing to do with astronomy. What I started to say is astrologers, probably years ago, actually took the nighttime sky and divided it up into both northern and southern hemisphere and divided it into 88 pieces. And those 88 pieces make our constellations. But one of the things, well, I should say that's modern astronomy, because other cultures have seen other things. But that's a whole nother story. We'll probably talk more about that later. Okay, so let me go ahead and kind of get things calmed down here. It's got a search feature, so let's go ahead and use the search feature and look for Polaris, shall we? And it will center on Polaris. How do I make that stuff go away? Oh well. Hopefully you can kind of see around it. I'm going to go ahead and zoom out. That's why I brought my mouse here. Oh, see the Big Dipper? There's the handle. There's the bowls. The bowl stars point to the Little Dipper. Oh, sorry, the bowl stars, these point to Polaris, and Polaris is actually in the handle, I was right, of the Little Dipper. One of the things I want to show you, I'm going to pull back up the time if I can, and see if you can see that movement of the stars. So I'm going to click on the minutes. I better go back in time a little bit. Okay, so that's 3:27 a.m. Can you see the diurnal motion? Hopefully it looks counterclockwise. So that's, I know it's kind of a slow movement, but that was what I was talking about. While we're here, I'm going to go ahead and add back the lines. Okay, so here's the Big Dipper. Actually, it's in a part of a larger constellation called Ursa Major, Big Bear. And the Big Dipper, we can use the Big Dipper to find Polaris. And like I said, this is the Little Dipper. So anyway, that was all to say what your next slide does. Really? Where'd it go? Looks like this. So I don't know how much photography any of y'all have necessarily done. I've not done a lot of photography, but you can catch like motion with photography. If you open up your shutter, oh, this, where to go? Where is my mouse? There it is. If you open up your shutter, and if we were to open up the shutter for the stars, we'd actually see Polaris in the middle, and it would not move, but the stars around it would move counterclockwise. So the word I have there, it looks like probably, oh, I guess I didn't have a word there. So we kind of have this sort of difference in kind of the stars we look at. Some stars will never set. Some stars that are near Polaris will never set. That's to say that even in the daytime, if we can see the star, it doesn't set. It's what we say above the horizon. So it's the bullseye sort of thing. And I already told you, and actually have it coming up on the slide, that the angle that Polaris makes with the horizon is your latitude. So if we are at the pole, what latitude is the pole? If the equator is 0, what latitude is the pole? 90. Yep, if we're at the pole, so you're at a 90-degree angle with the horizon. That's 90. So if you're at the pole, makes sense. Polaris actually is going to be what we say at your zenith. Make your bullseye, and basically, if you make your bullseye from the pole, you basically have all circumpolar stars. So none of the stars will set, if you could see them during the daytime. Circumpolar stars. So I've been saying this for a little while. The angle that Polaris makes with the horizon for you is that angle right there. Okay, that is your latitude. And actually, sailors used to use that to their advantage to know where they were going with regard to the equator. Not longitude, but latitude. Okay, oops, so do you guys already have that one? Okay. Cool. Well, here's one for you. Not only, we're switching gears. We're switching gears from the motion of the stars throughout the course of the night to the different stars we see throughout the course of the year. So, I couldn't decide how to do this, but if you see, I have like actually 13, not just 12, but 13 different signs on around the room. Okay, and you might recognize them. They're zodiac signs. Like I heard some of you are. I kind of asked your sign the other day. As I was putting these up, I'm like, I have never known somebody that was. Anybody in here know a Capricornus? Oh, you're a Capricornus? Oh, so like, do you call yourself a Capricornus? Is that right?
Occasionally, normally just go Capricorn. But
Capricorn. Yeah. Oh, that Capricorn. Thank you. That made my day. Okay. And so just, we didn't ask what Jasmine was. Jasmine, where are you? Leo. You're a Leo?
Pisces.
Pisces? Capricorn? I'm so glad we had this conversation. Ashley?
Taurus.
Taurus?
Taurus.
Wow, we're kind of lopsided. Yeah. So I have a, kind of before we get to that, here's the deal. So I'm going to be kind of behind here. But Earth, Sun, right? So we know that the Earth orbits, the Earth goes around the Sun. So does this make sense to you? I'll kind of start here and then we'll kind of go from there. Do you see where daytime, right? Nighttime, and I know this is a small thing, but it's not really a small thing. Nighttime, do you see where those are the stars, those are the constellations we're going to see, okay? And even though those, I'm looking at Libra, Virgo, Leo, Cancer, even though those stars are out there, I can't see them because the sun's in the way. Oh, good. Okay, very good. Now, one important thing about these constellations that I have up here, that we know people that are these zodiac signs, even if we aren't. One of the things about them is they all lie in the ecliptic, from our perspective. Remember what the ecliptic is? That is that plane that all of the planets orbit the sun in. So these are special constellations. Okay, very good. Well, the other thing is, I know, let's pick on, we have a couple Tauruses. So there's Taurus over there. Here in a minute, you're going to see a slide that talks about this. If you were Taurus, if you are a Taurus, then when you were born, this was kind of the configuration. This was where the Earth was relative to the sun and that set of stars. Okay? So we say the sun was passing through that constellation. That's what makes you Taurus. That's it. But you can't see Taurus, but you can see Virgo and Leo, Libra, and Scorpio. Okay, so there are different times of the year where you can see these different constellations. Sounds like you guys are buying it, so that's good. You know, sometimes you're like, I don't believe you. Okay, so the background stars that the sun was passing through gives us our zodiac sign. Okay, so it looks like this, what I just showed you. Now, this is kind of showing you different positions. Of course, the sun's in the middle, and you kind of see the Earth going around the sun, and we try to keep it at 100%. Okay, the Earth is going counterclockwise, and like I said, if you are if you are a Leo, for instance, then are you around August 21st or so? Ish? Okay. Okay. So that's how that works. Now, one of the things, Capricorn. One of the things is we have Capricorns, but notice I bet you've never met somebody who is an Ophiuchus. You're like, the problem is the astrology thing, which is not a science, but it's an interesting sort of thing to follow. The astrology thing kind of left out the fact that, and it's not much, but that for a few days here in the first part of December, so actually I'm an Ophiuchus. I know I don't call myself an because I call myself a Sagittarius. Okay? But for a few days, this is where the sun appears to go. It's the background star. So, anyway, I don't think they're gonna do anything about it. So, is this hidden from your slide? Ophiuchus is another set of stars. It's kind of a boxy, weird-looking sort of, I think, constellation. And it would be between December 1st and December 19th. No, so, yeah, don't guess that, don't guess that. This is just scientists kind of doing their science thing. Because,
Am I a Pisces or not?
yes, you are. Don't look at it. Don't look at it. Because it kind of scrambles everything, doesn't it? How many people's things changed? No worries. No worries. Okay? Don't want any identity crisis going on here. Okay. So one last topic on this whole kind of the Earth and the Sun and in general. So the Earth's axis of rotation is tilted, and if you see it on a test, it's going to be 23.5 degrees tilted. The other thing, though, and remember, you know, how it got tilted was probably got banged up against the side of the head early on. The thing about its tilt is that it is wobbling like a top kind of wobbles as it starts to kind of run out of energy. And you start a top, and the top's straight up and down, and then after a while, the top kind of gets this angle sort of thing going to it. It gets an angle, and it kind of does that sort of thing. So, but it's a long period of time. So, it's the, unlike tops, when they do this, they're kind of like the beginning of the end. They're going to topple over. Well, the Earth's not like that sort of sense in it, like a top, it's going to topple over. But it does go ahead and take 26,000 years to complete one cone, one circle. Yep. Okay, so Polaris hasn't always and won't always be the North Star. On here, you can see where right now you can see the axis of rotation is directed towards the star Polaris. But in about half of 26,000 years, 15,000 years, it's actually pointed in the direction of the star Vega, which is a very pretty star too. That's a long time. And then the thing is as it kind of does that sort of thing, and it orbits the sun, it actually has consequences to when the equinoxes, when all of the two solstices and the equinoxes, when they occur. So we're okay. You can kind of go with, what do we say, March, June, September, and December as our equinoxes and solstices, but that won't always be the case because of this precession. It's interesting to think about, though, cultures before us and stuff. So, very good. Well, these will be due. Do you want to go ahead and make them do the Monday after break? Or do you want to go ahead and do them, just bring them Friday? It's up to you. I will take them as late as the Monday after break or Friday if you just want to knock them out. Either way. Because you guys have a test tomorrow. And where did we have our test last time? Was it in here? Mm-hmm. Okay. I have a call in to see if this room is available. So kind of plan on it for here tomorrow at 10. And then if it's not here, look on the lab door. And also I'll send everybody an email. Don't forget that review video's out there. Okay, so it couldn't hurt. And remember, for your test tomorrow, you can bring your periodic table. I encourage you to bring your periodic table, and with notes written on the front and back of it. If you don't bring your periodic table, I'll bring like a black and white one of mine, just in case you forgot. All right.